Anytime I fabricate a part from a much larger blank, I use the cutter contact itself to tell me where the cutter is located. Knowing that the block is bigger than the final product, when the cutter makes contact with the part, I'll zero out the table, I'll zero out my axes on my digital readout, and I'll use the center line feature or just do the math by the numbers shown when the cutter makes contact with the block. Final dimensional passes are usually very light, and 9 times out of 10, they'll be a climb cut. This is a relatively small diameter end mill, and I could expect deflection if I were to just dive into this part, so I'm going to nibble away at the slot before I stay at depth and walk it out. I will come back at a later time and take a couple thousandths off of each side to remove any existing scallops that probably would show up if you left it as is. Using the same philosophy as the side notches, I will nibble away at the relief cuts on the side of this block, a little bit at a time. Now the deflection of this cutter for the back cut is moving away from that body. And now since I'm starting in and pushing the material away from me, the deflection of the cutter is going into the body. Be careful of that. It may get you if you don't leave enough material on your roughing pass. Same here, it's deflecting away from the part. Now it's going to pull into the part, so you can expect to see little ribs on these finished surfaces if you're not careful. Before I finish the flat surfaces on this particular feature, I will plunge the termination points so that when the cutter gets to the corner, the material's already gone and you don't get that squealing, nasty sound. If you want, go a thousandth or so beyond the required dimension for the corner only before you mill those surfaces. And any change in the load on the cutter as it goes across these scallops may result in stripes. Always use some kind of support material if you're going to bandsaw off a part that's not flush to the table. You do not want the blade pulling down on the part and moving your fingers closer to the blade. Always support the outside edge. Always take a good look at the geometry of the finished part and try to support the part with the most mass that you can. This part will ultimately be slotted right down the center, and the last thing you want to do is have it close up or come out when you put that slot in. Anytime you see me remove a part halfway through the process and put it back in, I'm usually taking it out of camera range for a measurement. Sweep the jaws to find your Y-axis center and proceed. The smaller of the two slots in the bottom should absolutely break through to the top surface formed in previous operations. You can see that the material just moved away, and now we have a large rectangular hole going right through the center of this. This will ultimately track the movable jaw. The next feature to be done here is the section that's going to retain the movable jaw. This is where the little plate's going to go. And you'll see this is a climb cut as well. That way it forces the material into the existing body of this little vise and eliminates the burr along that step. I'm using the center line feature on my digital readout to pick up the edges here and find the center of this block. Once the digital tells me where the center is supposed to be, I sweep it again just to verify. This is the end of the block where the lead screw will pass through. And lo and behold, guess what? This is a 4mm thread I'm putting in here. 4 millimeters. I had to go and wash my hands when I was done with this because I felt I was breaking out in a rash from touching that tap. Okay, metric represented. Same exact process used on the movable jaw as was used on the body of this little vise. Let the cutter tell you where you're at. Don't worry about edge finding. Don't worry about indicating. Make contact, set your digital, set your dials, and from that point you know exactly where the center of that block is based on the diameter of that cutter. That is strictly a contact cut, and that too. Now that I have my digital set on 0, I can make equidistant moves X and Y and have a perfectly dimensioned part without ever touching an indicator or an edge finder. Four holes in the bottom of this. They are approximately 1.5 millimeters in diameter, 0.62, 0.63. 2 will get tapped, and 2 are 4 dowel pins. Sorry guys, no metric threads this time. This is a 172 imperial thread. This is about 74 thousandths in diameter. It's approximately 2 millimeters. Quarter of an inch deep. It's about 6 millimeters deep. And like I stated before, make sure if you're going to cut off a part that's not flush with the table that you support it. You do not want it jerking down with the blade pressure and moving your fingers cantilever into the blade. It will happen. I've seen it happen, so be careful, even so small. Don't start that cut until you're absolutely sure and comfortable with what you're doing. This is not a very friendly machine. I'm going to bring the part to thickness using some ultra thin parallels and light pressure on the jaw. These Kurt vices are so powerful that if I wanted to crush this part, all I need to do is lean on that handle a little bit and away you go. So if you see me running back and forth more times than one, that's why. Light cuts, good results. This is the counter bore for the tip of the lead screw. It will intersect 2 of the 4 holes on the bottom of the jaw that we put in previously and allow the lead screw to be retained by the 2 pins. I grabbed a piece of 1-inch angle aluminum. This is 1/8 inch thick. It's about 3 millimeters thick. And this is the small plate that goes on the bottom of the movable jaw. So instead of getting crazy with fixture plates and crazy glue and double stick tape and flip flop, I'm going to approach it this way. Standing it up allows me to establish the width relatively easy. The material is rigid enough that it's not going to flex now. Moving it into a horizontal position, it's easy to find the dimensions that I need. Edge find the sides, edge find the front, or the back, whichever you want to call that, and I'll be right on location. The material is rigid enough that light pressure won't flex it initially. Now when I hit it with the center drill, watch for that part to just move like a little diving board. Watch it flex. Yep, little movement right there. And with the other hole as well. When you put the drill in, float the drill back and forth through that hole and it should eliminate any problems you're going to have. You're going to watch the flex is going to be considerably less with the drill because there's already a pilot there. Next step is to thin it out. Doing this operation in a climb cut, the pressure from the cutter will drive that shim up against that stationary jaw during the cut itself. And you're going to get your best results if your last pass isn't light. Take a pretty good bite on that so that you don't get any remnants from the previous cut. I'm going to build myself a little bridge with a pair of parallels here so that I can shut this vise down thinner than the actual part itself. And I'll show you what I mean here in a second when I put that little piece back in there. That is 0.60 wide, and the parallels I'm using are 1/8 of an inch. So the parallels are twice as thick as the part. The bridge method works very well for thin parts. The lead screw is being fabricated from an existing 4mm car speaker hold down screw. I know, I just didn't feel like single pointing anything, so I went to my hardware kit and I grabbed whatever I had laying around, and that's what I tapped in the vise body as well. I didn't know it was a 4mm until I inspected it, and I thought, boy, look, people are going to be proud of me on this one. Now, a good way to cut something off visually is to chamfer it first. Let the remnant, the shiny part of the chamfer tell you how long that cylindrical part is. That'll be your guide. It's a very good visual guide. Once you have your chamfer down and you have a little bit left, just press it up against the belt. And you know if you cut the chamfer off that you'll be right where you need to be. If you don't cut all the chamfer off, the part's already deburred. It's a win-win. The handle for the lead screw is a piece of 308 stainless welding rod. And the lead screw itself just has a small turn diameter on the front with a V-groove in it and a cross hole. These are the small brass knobs that are going to go on either end of the handle to keep it from falling out when you rotate the lead screw. A little back cut partially the way through, and then I'm going to visually put a chamfer on the front, move the tool around to the groove, put a chamfer on the back, and then put the parting tool back in and finish the groove after I polish it. The part will drop off complete. And with a little bias to your tool grind, it should drop off very clean with little or no burr. I need 2 of these. And guys, I would like to highly suggest if you're going to polish anything, make sure that there's no tools in your tool holder. If your finger for some reason wraps around that part or walks off the top of the part, you don't want a tool in the way.
Well, in case you haven't figured out what we're building today, it is a miniature drill press vise. And I guess the movable jaw is probably the toughest part of this. And let me show you what's going on inside the movable jaw, because nothing breaks through, nothing is visible, and it's fully functional and articulate. I'm going to use a couple of longer dowel pins here just to illustrate what's happening. 4 holes in the bottom of this thing. The 2 in the center are tapped, and the 2 on the end are larger than nominal. Not by much, but they are. Okay. Now at assembly, these pins are flush with the bottom surface. The V-notch on the front of this little lead screw is trapped on the inside of that bore by the placement of these pins. And I'm just going to stick it down there just to show you how that works. Okay, just like that. So if I were to pull these out, put this in, let me put it in off camera because I just can't do it. It's just too bent over. Hang on. Okay, that lead screw is now trapped because of those little pins. Those pins go tangent to that V-groove that I have in that shaft. Once the bottom plate is put on, the bottom plate will constrain these, retain those, trap them, whatever you want to call it, and away you go. If you're going to do this, make sure that it's magnetic material. Now I know these aren't because they're the test pieces, but the ones that are going in are definitely magnetic. If they're not magnetic and it's not a free floating fit, you're never going to get them out. So don't drive them in. You cannot break this thing down for maintenance 10 years from now. All right. Well, that being said, let's put this thing together. Take a good look at how it works.
This is a fun little project and can be fabricated from the materials to suit your needs. This project took me 8 hours to complete. When I walked in the shop in the morning, I didn't have any drawings, I didn't have dimensions, I had nothing. So basically I designed and built this in just over 8 hours, and that is along with filming. I'm going to put the plans to this on my Patreon page, so anybody interested in getting dimensions and possibly making one of these yourself, check out my Patreon site, and for a pledge, you'll get a PDF download. There are benefits, and that's where they're at, so drop by. This little vise was fabricated as an accessory for the miniature drill press that I'm building. If you have not watched that series, you should drop by and check out the fabrication of that. It's quite interesting. I do appreciate you stopping by. Thank you for watching. Wherever you are in the world, I hope you're well and safe. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out.